So here we go again. Separable differential equations. This I'm going to call the advanced level. It's advanced mostly because it looks scary, but it's not that bad. Step one, separate. Hopefully by now you guys go, oh yeah, step one, Miss Lynch is just saying separate. Yeah, we get to separate. We get the y's on one side, the x's on the other. This one looks a little weird because of this e, and then it's got trig, and we all kind of panic when we have trig. But if we first rewrite this right side, we might be able to look at it differently and say that this cosine x e to the y times e to the sine x, that's dy dx, right? I took that plus sign and I broke it into two parts. You've seen that 2 or 3 times at this point, definitely in different contexts, but it's still the same technique. So yeah, there we have that. Ooh, that is bleached out, isn't it? Right there in the middle. I hope that's not too bad in some of the other videos. Oh no. I guess that's a little bit better. Yeah, okay. I guess that's good. So, yeah, pardon that little delay. So this is a y. That's a y, e to the y. So now we need to move this e to the y over here. The x's can all stay there. We're going to move the x over, so we're going to multiply both sides by dx. So this becomes 1 over e to the y dy equals cosine x e to the sine x dx. I haven't done any calculus yet. All I've been doing is moving pieces around. E to the y, 1 over e to the y, hopefully we remember that we could change this y to a negative sign and get rid of this fraction. And really, well, I'm going to leave it 1 over e to the y. I'm going to leave it like that, but I'm also going to say that this equals, and I'll do it in different color, e to the negative y. Those are the same things, right? That's e to the minus y. So, yeah, that's good. And now we're really ready to integrate. I'm going to integrate this side. I'm going to integrate that side. Let's worry about this side first. I told you a long time ago, when we have e to the sine x, we actually have two things that we can, two different ways we can choose to integrate it. Step one is we can choose that it's going to be e to the sine x is going to be u. So we're going to say u equals e to the sine x. Therefore, du is e to the sine x times the derivative of sine x, which is cosine x, times dx. Pardon me for bringing it around, but look at this. E to the sine x cosine x, that's the same as that. So this substitution basically turned this right side into the integral of du. And we remember that when it's something like that, we just can put a 1 in there. If we feel like we need the placeholder, we can put a 1 in there. In the right side, I have e to the minus y. That works out the exact same way. I can say that u equals e to the minus y. So therefore du equals e to the minus y times the derivative with respect to y of negative y is negative 1 dy. So that's just, so that more or less works out to be everything here except for there's no negative sign. So that means that what I'm going to be integrating is the integral of negative 1 dy. So I have that. I'm sorry. I should have probably used v because I'm doing it on both sides. I usually wouldn't use substitution on something like this, but it's good to see. So anyway, we'll have v on this side and u on that side. Great. Now we need to integrate. Well, the integral of negative 1 dv is just negative v. and the integral of 1 du is just u, and then we've got to put plus c. Well, we know that v is e to the minus y, so it's negative e to the minus y equals u is e to the sine x, and then plus c comes down here. If I want to, I can now start trying to solve for this negative y, or solve for y. So I'm going to first multiply everything by -1, so that gets rid of that. I'm going to put a negative sign over here. Negative c, positive c, it doesn't actually matter, so we can leave that alone. I want to get rid of the e, so I'm going to take the ln of both sides. So I'm going to get negative y equals the ln of negative e to the sine x plus c. This is all absolute valued. There's a negative sign, so I'm going to put it to the negative and make that positive. So I am done here. I can clean it up a little bit. Some of you might remember your exponent rules. And if you do, then you can definitely clean it up quite a bit. But I'm going to rewrite it up here so we can just see it. So I have y equals the opposite of the ln of the absolute value of negative e to the sine x plus c. And I'm going to clean this up, and we should, well, other than maybe turning this into a reciprocal, there's actually not a lot I can do now that I'm really looking at it closely. Yeah, we're basically done. That's it. I'm sorry that I hope I didn't feel like I led you on too much. That's good. Well, I guess sure. Y equals the ln of 1 over, right? We'll move that -1 inside. Negative e to the sine x plus c. Problem solved. Okay, there you go.